So, yeah, today, I thought I'm bored. Let's just freaking do another like I'm bored series where I'm just doing random coding. But this time around, we have a little bit of assignment which we have to do, the binary search tree where you just implement all the functions inside there, like this one, insertion and then deletion, search and display it in, whatever, like in order, pre-order, yeah, and then yeah, we can do post orders what we wanted. So anyway, let's get started without me yapping too much. I'm really bad at doing intros. I'm really sorry, but anyway. So first up, let's do sorry, I don't know why I did node, but that's kind of doesn't make any sense. So let's just get a struct node to store all the data in it. So, oh, you know what? I'm gonna make this thing generic. Let's try this thing generic because we want to take any data that we want, right? So, and then node left, and right. Okay, let me just fix this thing real quick. And then we have a constructor where we're gonna take the data in it, and then we're gonna have this data left and right is null pointer. Anyway, yeah, we're done with this thing right now. So on to the second part, insertion of a node. So since we already have like the node that stores all these data, the value that we want to store in the node and the left and right pointers, which indicates the left and right child. Just say left and right nodes children, maybe. And then this one is the, of course, obviously gonna be the value. And then so to create a node, we will have the data that as the parameter that we want to take in, and then we're gonna assign the this data equals the data that we passed in, and then the left and right is the null pointer, of course. So after this, we're going to make a insertion function, which insert, I'm gonna call this thing insert node, and then have node t, call this thing root, and then t data. So we want to create a root node which has the data passed in as well. So yeah, so we're gonna check the base case, right? We have the base case if we're gonna check if the root is empty, then we're gonna do. So if the root is null pointer, and then we're going to return node, and then t star, then I'm gonna take the root. That's all we have to return. And then I never have to check. Yeah, I'm gonna check if it has like some value. I mean, if it already has a root, then yeah, then we're just gonna recur down the tree. Yeah. So we're gonna do if the data that we passed in is less than the root, have the data inside the root. Yeah, the node, of course. And then we're gonna go to the left. We're gonna insert it from the left child. Else if data is more than the root has data in it, and then we're gonna recur down the right. And then after that, we're going to return root. This is like, how do we call this? The pointer. I think we call this the unchanged. Sorry. Point. I can't write, I'm sorry. Okay, so this is great now. So we already have all the cases in here. And then class T, and then we're gonna do delete node, I guess. I'm gonna explain this, okay? Let me just write this thing first. And then we're gonna take in the node. And then can we call it the root or just like node? I think we can call it whatever we want, right? whatever, t, oh, how should we call it? It's gonna call data to be del, to be deleted, you know. So, before we proceed to this one, we want to have a, you know, a minimum value finder, right? So we want to, I'm gonna explain later like why we want that, because we want to find the min value, you know, just in case of like, just in case of when that node that we want to delete it has two children, right? And then we want to think of like this kind of conditions as well. And there goes, already wrote for me. Tamlin is quite smart though, actually. So we already have this one, which is super smart. So to delete a node, we have to consider like three conditions, which the first condition would be like if that node has no like children at all, like what do we do with that? And another like condition would be like if that node that we want to be deleted um has one children. It doesn't matter if it's left or right, but if it has like only one child, and then how do we do it? And the last one should be like I mentioned earlier, if that node has two children, and how do we do it? So let's just go with the first thing, the first case that we want. Let's say if that node, let's gonna write the comment first, just be a good developer, just yeah. If um if data to be deleted less than um root, and then point to the data, which we'll go root and access the data, of course, and then yeah, and then we go root to the left just equal to delete node, which will use the recursion, and then we're gonna have else if yeah, less than root data and then current to right. Oh, and also sorry, I forgot about this though. I forgot that if that node is, if that root is an empty one, we have to consider that. Should be the same as here, but instead we don't need this one, but you know, if the node is empty, if the root is empty, and then if root equals no pointer, and I'm gonna return root. You can return either null pointer or root because two of them are like similar anyway, so you can return which of them. So I'm gonna change this to else if just a search function. Sorry, it's not to be deleted, like recur uh find out where the node to be deleted, find out where the nodes to be deleted belongs to. If it's, you know, if it's less than the root, then we're gonna go to 11, right? And then we're gonna have the else case. This is a big else, okay? Call when found that node. Then what do we do if we found that node? In case of that node has no children, and then what do we do? So we're gonna say if root, if the left child, okay, is null. We have to check first. Is null, and then also the right child is null too. Sorry, right child is null too. And then it is safe to delete. You know, we don't want to delete one and then like we don't consider the other. So that's just like, that's just gonna be disastrous. It's gonna completely destroy the tree, of course. equals to null. Or can do null pointer, but I think we should use null instead. Because we want to return the value 0. We don't want to delete the address, or you can delete the address, but you can do whatever we want in this case. But I like to have it to be like 0. Yeah, if that node has only have one child, so else if root to the left is null, and then we're gonna have node, and then we're gonna create a temp, basically a temporary like store to store that node. In this case, right node, and then like we're gonna delete that root node, and then we're gonna point that root node to the right child. I don't have the diagram for this, but I really want to explain, but really sorry, but I don't know if I have the diagram for it. So I'm just like going raw at this point. I try to go from what I remember and with my reference as well. So it's the same thing. So I guess I should explain a little bit maybe. So I want to create a temp. Okay, a variable called temp, and then we're gonna store that root, the left child of that node. Okay, left child of that node. If we found the root, if that sorry, if that node has only left child, which basically means the right child is empty or null. Okay, want to create a temp variable, and then you store this value, the left child, to that temp variable, and then you delete um that root from the memory address, right? And then you point that address to the root that we set it, which is the left one, left child. So yeah, hopefully like you understand if that node has two children, and then what we have this is the last case, by the way. Is the last case. So node um T, no, I don't want to do this yet. Maybe we should do it right now. I don't know. So we're gonna create a temp again, and then this is where the main value node come in. Okay. Gonna point this thing to the right first. So basically, you want to loop to find the minimum value in the right node, whatever, and then you copy that data into that temp itself. Oh, template, sorry. Yeah, in this data, this one, and then copy it to the temp, and then you assign that root to that data, and then from the right one, sorry, root right, and then we use the recursion to delete the right node, obviously. So yeah, that's all it is to it. And then lastly, just return the root if nothing happens. And what else do we do? Search. Okay, search template. Okay, so we're gonna consider the base case if the root is empty. Always, as always, do a little bit of error handling. No pointer, and also we have to check simultaneously if the root and data equals to key itself. If it's equal, like or the null or equals to the thing, then we're just gonna return that node. Otherwise find the node within the given key. And then this thing is when the root, sorry, not root, should say key less than root, and then data, and then you're just gonna like return search node and 11 key, else if that key, it's also it's kind of similar to Oops, sorry. Kind of similar to the insertion. Turn search node and then to the right. And then if nothing happens, just return search node, and then we're gonna do root and then key. That's it. Oh, sorry, left. This one should be left. So I think lastly, you have to display it in whatever order. Template class T in order traversal. Sorry. In order traversal. So in the in order traversal, like all you have to do is just like this is a base case. No, it's not a base case, sorry. If root is not null pointer, and then like in order traversal, you would like go ahead and go to the left first, and then you print that and then go to the right. So it's already like done over here. And then we're gonna probably copy this function because it should be the same thing anyway. So the pre-order traversal, I think you will print left, right, and then root, and then post should be root and then left, right. So you just have to change the position a little bit, and that's it. I think that's all you have to do. So yeah, display. I think we're done here. Big O notation. It's just like all of them are basically just big O of n. So depending on like how many nodes you have, it's gonna go into linear time complexity. So anyway, main function here. Let's first of all create a root node. Let's point it to null pointer, and then we're gonna we do root equals to insert node. We're gonna insert. What should we insert? Like, let's just do an integer, and then root, and then we're gonna do like I don't know, maybe number 8, I guess, and then we're gonna duplicate this a bunch. Display the tree in order traversal. Hang on, before I do that, let me just run the code first. See, I freaking knew it. Expected for function style cast line 29. Oh, new. Okay, we need new keyword. I think it works now. After deleting 10. I forgot to like then a function here because this thing is just empty. Template class T bool check node. No, I'm doing void. Yeah, void. Check search, and then we're gonna take the root and then T key. Using the search function, and then we're gonna go with search node root and key that you passed into. No, actually this is have a return value, so you need to be a little bit careful here. You cannot do it like that. So we're gonna call this thing found equals this one. Okay, so this is the found. Check if the key is found. If found is null pointer. No, not null pointer, sorry. I mean, I guess you could do that first, I guess. My brain is kind of getting a little bit, Node is found. And then else, I guess. Else. No, it's not found. and let's just std cout. uh Searching for 10. Not found because we already deleted. It's found in the BST. Alright, good. We already did it. Yeah. I think we're done here right now. Left, print, right. Left, right, then print. Print, left, right. Okay, I think we're done here. Yeah, I guess we can end the video here. I think we're done now.